Welcome, welcome, welcome. Ymmanuel here. Hope everyone is doing great. So, today I was checking out the new MaterialX plugin for Substance Designer, and since I saw a lot of questions about how to install and use it, I thought it would be a good idea to explore it together. So, thanks to everyone that is here, and I see some people that we have already seen here in the chat. So, I think it's a good time to start. Okay, what I think of is to first start with how to install the plugin in Substance Designer. Since if we go to share, for example, wait a second. If we go to share, for example, and go to the plugins, then MaterialX, I see a lot of comments about asking how to install and how to use the plugin. So the first thing that we need to do is know that the MaterialX plugin is actually not part of the Substance Designer download, so you need to download it from share. You can just visit this website. Let me copy paste the link on the chat so you can just click it if you want to follow along. So let's download it and see what is this all about. If I see that some of you are not that familiar with MaterialX, so let's see. An easy way to understand it will be, wait a second, I'm looking for a link. Okay, here it is. Here is the explanation of MaterialX and Substance and Lucasfilm and Autodesk and all the teamwork they did to make this happen. So what is MaterialX? Basically, MaterialX is you know that every renderer has its own shader and has its own material definitions. Like for example, Arnold has the standard surface. The Redshift has a principal shader called the RS material and all that stuff. So it seems like every 3D application and every renderer make an effort to define and standardize the way the materials are defined. So what the people of Lucasfilm, ILM, and some other important people in the industry was to make a sort of a new standard that is open source, unlike some other solutions that have been made to try to fix this issue of multiple different material definitions in different softwares that usually cause a lot of issues on a pipeline. They try to define a standard that can be used by multiple applications. It's open source, so everyone can see what is behind it and can, thanks to that, adapt, make a plugin, make some implementation of MaterialX in their current pipeline in order to have a common material definition along all the pipeline, so they can, for example, if they need to render something in Houdini and Mantra and mix that and also render another part of a scene in Maya with Arnold or whatever, they can just use the same definition and apply it overall the pipeline, so they can facilitate the way rendering and texturing works overall. So this is the PDF that the people of MaterialX and Substance shared. There is not a lot of definition. It's more just a show off of how they use it in some of the Lucasfilm projects. But basically what it means is a new open source standard that anyone can use or implement that helps define shaders, so you can use the same shader and the same configuration all over a pipeline. It doesn't matter what applications that you use or what software or operative systems or whatever. It's all the same. Okay, so to make it this easier and keep going, let's get started with how to install it. Okay, again, if you have any questions, just let me know. The first part is, as I said before, it's go to Substance Share and download the plugin. You need to go to Plugins, then you can go in Substance Designer, and you'll find here the Substance Designer MaterialX plugin. You download it, and you're going to get something similar to this. Let me open my download folder. Okay, this is what you get. A zip file called Substance Designer MaterialX plugin. You extract it, and once you extract it, what you need to do is let me open the folder. Here's the folder. Okay, here's desktop and the folder, and you'll find this folder called SD MaTeX plugin. This is the content, what the content looks like. Okay. Now you need to copy this folder called SD MaTeX plugin to your documents, algorithmic, Substance Designer, Python, SD user plugins, and paste it there. I already have it, but it's basically the same folder. The only thing that is missing at the moment is this folder called MaterialX, but I'm going to show you how to add it. And this is the easy part, but adding this folder seems like being the main issue for many people that are trying to use the plugin. So to get that folder, all you need to do is to search MaterialX and GitHub, GitHub, and you'll open this page. And in this page, almost at the bottom of the page, there is this section called Pre-built binaries. You just need to click on this binary that is called Microsoft Windows Visual Studio 2017 64 bits, and you will download another file. If we go to open folder, see the downloads, it's downloading right now. Let me delete this. CJ Adams, PC only. Actually, no, you can also install it on Mac, but the process is a little bit more complex because you need to compile the Mac version. Maybe I'll try to compile it and share it on a link, or upload it somewhere and share it on a link. But the Mac version is a little bit more complicated to install. Okay, let's see. Okay, here it is. Right, now we extract it again to a folder, and this is this one. We open the folder, and this is what the folder looks like. Okay, now this is here's the important part. The first thing that we need to do is to rename that folder to MaterialX, and then copy this folder inside the folder that we copied previously in the documents, SD MaTeX plugin, and paste it. If you check this out, this folder and this folder, the content is basically the same. Okay. Now, with that, once you open Substance Designer, you should be able to see. Let me close everything so we can start from scratch. Close. Actually, let me close Substance Designer because I have something in the tree viewport. That way you'll see everything from scratch. Okay, let's wait a second. Substance Designer to open. Okay, now it's open, Substance Designer. By the way, I'm using the latest Substance Designer version right now. I think it's 2020 1.1, if I recall correctly. Now, if you install it correctly, again, just to be sure, is Documents, Algorithmic, Substance Designer, Python, SD User Plugins, SD MaterialX plugin, and the other part that we downloaded from GitHub and renamed the folder to MaterialX, it's inside. If everything was done correctly, you should be able to see this icon here. That's the MaterialX icon. Now we go to new MaterialX graph. We can enter a graph editor that will only work with MaterialX nodes. There are some, this is a sort of a beta release, so there are some issues with the UI, with the Substance Designer UI, but even with those issues, the plug, you can still do a lot of stuff with it. Okay, so let's see. The first thing is that we need to use Array for this. I think that there is a way to use OpenGL, but I haven't found it yet. I'm also, as the stream says, I'm also exploring MaterialX right now. So let's see how far can we push the plugin. Okay, one important thing is that if we check the plugin that we downloaded, and this might be helpful for a lot of you. If we go to Documents, Algorithmic, Substance Designer, Python, SD User Plugins, there is a folder called, an SD MaterialX plugin, there is a folder called Doc. If you open this folder, here, let me open it here. There is a readme.md file, that is a text file. You can use a text editor to open it. And it has all the basic rules on how to install, how to use. And for example, here it also explains a little bit about how to compile it for Mac. Now that you were asking, CJ Adams, here's where it says how to download. Here's, for example, the part of Visual Studio 2017 64 bits. What else? Here is a little information of how to create the basic materials. This is the first thing that we're going to do, try to emulate this part of the text. How to expose parameters, how to tweak them. Something a little bit more information about how to use textures. I'll try to also explain some of the stuff that I found about this. And how to use normal maps, and this part that is about the GL viewport. This part I haven't checked it that much, but maybe we can also try it out. Then we have here material export, material views, subgraphs. So basically, if you read all this, you'll get some sort of idea of how everything works. If you are a little bit, if you know a little bit about how shaders work. Then we have here some samples that include a graph and some samples, I think, and another readme file called floor.md with additional information. But in reality, I didn't find this too useful, right? So basically, all I'm guiding my knowledge from is this file and another file that explains how to use let me find it, how to use MaterialX and how MaterialX is defined. Okay, I'll put also that link in the chat right now if you want to check it at a later time. And it helped me a lot to understand how to work with MaterialX when I didn't knew too much about it. Okay, so let me write this in the chat as well so you can have it. There you go. What else? Okay, so let's start. The first thing that we need to do when we're talking about MaterialX, as I told you, is first check that you are using iRay. Then create a node called standard surface. Standard surface is the basic definition of a material in MaterialX. As you can see, if you are used to work with Arnold, or I think also Mantra and V-Ray mainly, I think Redshift as well, but main renderers is basically the same structure. We have a base that includes the base intensity, the base color, the diffuse roughness, the metalness. Then we have specular with all the information about the standard information of specular. It's really similar to the standard surface that you can find in Maya in Arnold, or well, actually in Arnold in any plugins. Specular color, specular roughness, specular IOR, etc. We have also the transmission, subsurface, sheen, coat, thin film, emission, and geometry. Okay, so the first, after adding the standard surface, the first thing we need to do is set this standard surface as root. Once we set it as root, we should be able to see it in the 3D viewport. Let's see if we can see it here. Okay, let me first save this graph. Desktop, MaterialX graphs, okay. View, okay. Okay, material preview. Okay, seems like, let's check if it's working. Okay, seems like it's not working. These are some of the bugs that I found. So let's close this again. Go here to OpenGL file, new MaterialX graph, and I think if you check this out, it actually automatically switch me from OpenGL to iRay. So in theory, it should work now. Set as root. Okay, now you can see that it changed the color from a gray to a white. So now if I change the color, we actually see some changes in the iRay viewport. Okay, now with that configured, we should be able to create our first material. So for example, if we use a noise 3D color, here we can now set the color like that, and here we can see the color. This is basically a 3D noise that I'm connecting directly to the color. Okay, now it's working, and I think that the easier way to test how it works will be to create a shader for Painter, Substance Painter. So for example, if I set it this way and I export to Painter now, if we go to Documents, Algorithmic, Substance Designer, you'll see that after opening Substance Designer with the MaterialX plugin one time, you should be able to have this SDMatX folder at the same level as the Python folder in which we installed the plugin, right? So now here, if we open it and open Painter, here we have the shader that we can use in Painter. Let's rename it to test, for example. And if we copy this one and then go to Documents, Algorithmic, Substance Painter, Shelf, Shaders, and paste it here, again let me find the path. Okay, again the path is users, your username, Documents, Algorithmic, Substance Painter, Shelf, Shaders. There you add the output that was generated by Painter. For example, if I delete this one and click again export to Painter, and open again the folder, you'll see that a new GLSL file will be created. So now if we open Painter, let's wait it a little bit for Painter. Any questions so far? Feel free to ask. Tell me if I'm going too slow or too fast. Okay, we go to Painter, then go to File. Let's open the basic Preview Sphere project. And if we go here to the shader settings, we should be able to see our test shader. Here it is, test. We open it. And the first thing that we notice is that it no longer matters what is in the layer stack. It gets completely ignored, and we have, let me disable the displacement, and we have just the common parameters of the shader, but now the shader is showing without any other extra information. Also, the scale seems a little bit weird because here in Designer we can see it, how the noise is really small, and here in Painter we see the noise too big. So let's start by trying to see in Painter exactly the same that we see here. Okay, I think that the first thing that we need to do is to play with the position of the noise. I'll try to make it a parameter of the shader, so that way when we open the shader settings, we should be able to control the noise here in the shader parameters. So let's close Painter for now. After checking a little bit the MaterialX version 1.35 final PDF that I showed you in the links, I found out that the noise 3D, if you want to scale it for any sort of noise, you need to play with this position tree float that you can see here as an input of the node. Now to do it, what we're going to do is first create a float 3D. Set it, for example, to 1, 1, and 1. And let's create a node called position and create a multiply. The position node will actually get the default values. It's similar to not having anything connected, but when you multiply it by something, you can actually modify the position. So I'm connecting the position and the float 3D that I created to the multiply node, and the multiply node as input to the position of the noise. That way, for example, if I change this value to 100, you can see that the noise is scaling, right? Change it here as well, 100. Or if I change it, for example, to 0.5, you can see how everything is scaled, right? And it's scaling in the X, Y, and Z axis. Now, to have it as a parameter, what we can do is right click and then click expose. This will make this node a parameter that we can use. And if you open the details of the node that you exposed, you'll see a lot of extra parameters here. Let me expand this part. Okay. You see a lot of extra information here. We're not going to worry about this right now. We're going to talk about it in a bit. Okay, let me check the chat. Kennedy asks, in a nutshell, what MaterialX does. I mean, a new material, an easier way to use materials. I'm a bit confused. Okay. Actually, what MaterialX does are shaders, not necessarily materials. You remember how in your Unreal Engine or in Maya or in any application, when you create a material or a render, you actually create something called a shader network, right? Not a material, but a shader network. A shader network is a definition of how the light and the colors will react and interact. It's very similar to the PBR standard material that we know in Designer, but it's actually more about, we're not creating a material, we are creating the PBR shader. If we put it in a really simple term, we are creating here, if we go to materials, well, you know that we have these presets here in iRay, and if we go to OpenGL, for example, we go material defaults, we have these presets that are the physical metallic roughness, physical metallic roughness, coated, etc. All these are shaders. What you're creating is one of these, not a material, but a shader, right? This is really important in terms of creating complex materials or creating high definition materials. For example, what this is for, if you are, for example, are working in Unreal Engine and you want to set textures for a terrain, you actually you cannot, if you try to set only a material in that terrain, you're going to need an extremely big resolution, probably something 8K by 8K. That is extremely memory intensive, but also but even with that, you will lose some resolution on the terrain if the terrain is too big. So a way to avoid that is to mix different materials, and the way you create this mix of materials is a shader network. What we're creating here is that shader network. What MaterialX in Designer, what is giving us is the ability to create these shader networks. That way, if we want to create complex materials, like for example, skin or a terrain material or something similar, we now have the possibility to do it directly in Designer and expose it from Designer via MaterialX to different renders in different 3D applications. Okay, from what I know, the main renders that are already working with something like that, I think that you can find some efforts for that in Blender, with Arnold, with V-Ray. Also, I think with Unreal, I need to check that out. But in theory, you can use these shaders from MaterialX with all that. In Painter, if you were here when I had Painter open, what you create is that shader, that PBR metal roughness or that PBR specular glossiness shader that you use in Painter, right? That's what we're creating right now. Okay, so let's continue. Again, if you have any questions, don't hesitate to ask. Now that we have this shader, let me go back to iRay, and we have this control that is exposed for this part. We should be able to modify it and see the parameters in Painter. Okay, another question. Exactly, Kennedy. Kennedy asks, okay, this creates a shader and this is creating a tile-able shader network without creating an X amount of resolution, right? Yes, exactly. That is what is happening. One of the main things that they talk about in the presentation, the Substance team, when they talked about the MaterialX plugin, is that, for example, you can have high resolution detail with a lot of zoom, thanks to these things that you are using a shader to create the material, and not only a texture. For example, let me check this quickly. Let me find it here. Okay, here it is. One of the things they showed in their presentation was BBA date. Let me see if there is a full picture of it in the PDF. Well, another benefit is that now with MaterialX, you can create materials like bubbles or like coated coated matte paint for cars or crystals, glasses, stuff like that was impossible to do with only textures. But now with MaterialX in Painter, in Designer Story, you can do it. Let me see if they can. Okay. Well, the images are too small, but when one of the things that they showed was that, for example, they had the ability to create with a lower texture resolution dust material. They were able to create a material that is capable of handling an extreme zoom in order to keep it clean even in close shots. It's something like when you create a procedural shader inside Redshift. Yes, Kennedy, is exactly like creating a procedural shader inside Redshift. Yes, we can use these shaders. We can export it in a way that some of the renderers can understand it. That's why MaterialX is trying to be a new standard. It's CJ Adams asks, is this a bit like OSL but a graph rather than code? Sort of. I think that you can do still a lot more with OSL, but it's more like using the native, that instead of using Substance Paint or Substance Designer to create a material, using the native nodes in Cinema 4D, in Blender, in Maya, in Modo, or whichever software that you're using. Okay. I don't see any more questions at the moment, so I'll continue and then I'll check the chat if you have any more doubts. Where were we? Okay, we created a basic shader. We set it as root. We added a 3D noise as color, but we saw that in Painter, if we use the color, that if we use the color, what we saw in Painter, the scale wasn't right. So to adjust the scale, we decided to modify the position input of the 3D noise by adding a position and a flow tree and multiply them both in order to adjust the size. And then we make this node exposed so we can modify it in the shader. Let's export this to Painter, for example. Again, this is exported to the Painter folder inside the documents. Modify this so we can see. Inside the documents algorithmic substance designer SDMatX Painter. We get this file and we copy and paste it to the shader shelf in the documents. So we delete this. Let's call it again test. Let's delete this for now. And let's open Painter again. Campy3D says you can output to OSL. The syntax is not that different. Yeah, exactly. Actually, it's also really similar to MDL if you have worked with it. Okay, again, we open the base, the standard. Let me minimize. We open the standard preview sphere project. We open the shader settings. And we change this shader. Kennedy, you can see here, for example, in Painter, here's where you select the shader, right? You select PBR Metal Rough and Isotropic, or non-PBR, Peg Gloss, or whichever render. In this case, we created a new one. It's called Test. We select it. And if you can see, here we have this node called flow3_1. And now we have these three additional parameters called flow3_1, X, Y, and Z. And the initial value is exactly the same value that we said initial. that we have here, 0.5, 0.5, and 100. So now with this we can modify it, and we can see that we can now adjust the scale, something that we previously weren't able to. Campy 3D says, yeah, MDL and GLES are basically the same. You know, you can learn. Yeah, it's basically the same. The main difference with MDL is that it's open source. So everyone, instead of only NVIDIA having the source, anyone can get it, modify it, adapt it, integrate it without an issue. It's pretty similar. In the end, it's the latest new standard to standardize everything. We had many new standards to standardize everything over the years, but the MaterialX, since it's open source, has been the most promising lately. Okay, so now we have this. But again, if we change the shader, for example, to the PBR anisotropic, that is the standard of Painter, we see that this shader actually uses the information from the layers, right? Like for example, here, if I add this material here and see the base color, let me see the base color. We actually see the base color here. But if we use our shader that is called test instead, it doesn't matter what this layer stack shows. It's overridden by our parameters. Okay, so we need to fix that. But before fixing that, let's play a little bit more with the standard surface. Let me close again Painter. And we can, for example, to make it clearer, we can call this base color scale, or scale only at the moment. Then we can add another float, and let's connect this float to the metalness, for example. Let's set it to 1. Now in theory this is metallic. Let me change here something. Camera. Let me set the resolution 720 by 720 to make it faster. Okay, otherwise I'm probably going to have some issues by streaming and rendering in iRay all the time. Okay, let's keep it like that. Now we have this float. Again, we expose it. Now let's call this, instead of float, let's call it metallic. And let's add another value. Again, another float. And let's call this roughness. And let's connect it to the roughness. Specular roughness. Okay, so now if we go to the standard surface shader, we see that the base color is connected. In the specular roughness is connected. Also, we have here full control, unlike with a traditional substance designer graph that we are forced to use, for example, metal roughness. Here we can actually change the IOR or change the specular color to make some non-realistic materials, because basically we are working directly in the shader instead of only in the material. Okay, let me see some questions. DJ Adams is asking, does this fit in with things like render delegates, Hydra, etc.? Yes, they probably probably yes. I haven't checked that much the Hydra and all that stuff. I assume they are working on integrating MaterialX, mainly because one of the main pushers of the initiative is ILM, and they have a lot of power over those kind of requirements. Let's see. Okay, we have now metallic and roughness. We have exposed metallic. Let's expose a roughness as well. And now that we are here, let's export to Painter again. Again, we copy this and paste it here. We don't need test anymore. Let's rename this to test and open Painter again. It's a little tedious because we need to close and open Painter in order to load the shader. That's also why I'm using the sphere project to make it quickly. Okay, let's see. Now here in the shader again, we change with our test that is in the shelf. And if we close the common parameters, now we have the 3 scale parameters that we have initially, plus a metallic parameter and a roughness parameter. So now we can control the metalness and we can control the roughness. For example, here, roughness, metallic, and again the scale that we had previously. For example, here we can put 50, 50. We'll really need in Painter some Control C to also affect the shader parameters. Okay, 50, 50, 50, and now we have something very similar to what we're looking here in Designer. If we change this as well, I think here we can set it to 1, 1, and 1. And this should work. Yeah. Okay, now we have something similar in both cases. Okay. Now, with that solved, the other issue that we have is still ignoring all the stuff on the layer stack. It doesn't matter what kind of material we have, Painter is fully ignoring it. So I think that now we can fix that. But first, I want to let you know of a bug that I found that was causing me some headaches a little earlier today. As you can see here, I have 1, 1, and 1, right? If I export to Painter, let me see if I can reproduce the bug again. Again, we delete this SGL that is in the shelf of Painter. We copy the MaterialX graph. We paste it. Let's rename it again to test. And open Painter. Okay, let's see the chat while I'm waiting for Painter. Okay, Campi says Hydra is USD, right? USD is basically a connection between the scene graph and the renderer. MaterialX, the way I understand it, is just the interface and I/O system to translate a material. Yes, MaterialX is basically like a common language between different renderers in order to understand themselves. So in the end, for it to work with Hydra, for example, Hydra needs to add a translator from MaterialX to the standard that they have defined. That's the same with Redshift, with Arnold, with V-Ray, and all the other renderers. And with Painter, what happens is that the plugin, what it does, it actually translates the MaterialX node directly to a GLSL file, which usually it's already understood by many renderers. One of them being Iray and being actually the Substance Painter, both OpenGL and Iray. That's why it's working with Painter. So again, let's open the preview sphere. And let's change again the shader to test. And here is the issue that I found. Probably has something to do with the interface of Painter. And the issue is that when we had an initial value that is greater to 1, we had, I think, 100. We were able to surpass the 100 value in the scale. But now even it doesn't matter what I do. If I try to add a bigger value, it still creates a rounded to 1. It doesn't matter if I create if I set it to 50 or 99 or whatever, it maxes out at 1. And that is not necessarily what we want. A smart workaround that I thought of will be here in the material to add to this another multiply node. Here add a float. And multiply this value by, for example, 100. Okay, my bad. Let's add a float 3 nodes. Now let's multiply this value by 100. 100 again. And 100. And then we can set these values to 0.01, for example. And that way we can use the 0 to 1 range that is forced right now at the moment by Painter, but we can have a bigger range of action. Okay, now if we export it again to Painter, again copy this guy and delete this and paste it here. I'll keep it now as MaterialX, since I understand that you already saw the process a lot of times, so you probably understand it as well. Okay, let's open now the preview sphere. And let's change the shader again to the MaterialX one. Now, even if we have only a range from 0 to 1, and still we cannot go further, we have all the range of values. Okay, with that said, now let's try to make the plugin to take into account the layer stack. Let's close Painter again. And first, we need to go to this guy. Let's start with the metallic and roughness. I think it's easier to understand it there. We go to the metallic, and in the metallic we said we know that the metallic, since it's a value and not a color, we want it to be in the gamma type linear. And in sampler usage, let's set it to metalness or metallic. I don't remember how it's called. Here it is, metallic. And then let's go to roughness. Roughness again is linear because it's information, not a color. And again, in sampler usage, let's select roughness. Here it is, roughness. In theory, that will be enough to make the shader recognize the layer stacking painter. Because if you see here, one of the inputs is the default value. And by connecting, when you expose it, you add this part of ranges. All this information is added to the node. If I create, this is a float, right? So if I create a float, this is all the node information and parameters. But once I expose it, you can have all this. And with all this, you can define the standard gamma type that the input will be, and also the sampler usage to be used by Painter in this case, or by any other MaterialX implementation, etc. So now if we export to Painter, let's delete the one that is in the shelf, let's copy it again, and let's open Painter. By the way, thanks MP3D. You are answering a lot of questions and you're helping me to keep the stream going. Thanks a lot. File, recent file. Let's open the previous sphere again. And now let's first delete the stack. And let's select now the MaterialX shader again. Now, if you see this part, the parameters here have disappeared. But now in theory, we add a fill layer and say the fill layer will only affect the metalness. Now the metalness is controlled by the layer stack, instead of a parameter directly here. And if we do the same with let's create another fill layer, but this time this one was metal, so this one let's make it the roughness. It's the same. Now we control the roughness, all because here we added first the gamma type that is expected, and second the sampler usage, so that Substance Painter can understand how to interpret that channel once there is a layer stack. Okay. Let's see, what can we do next? Okay, first, also let's notice also that if we select this color, it doesn't matter what we set it up to, it's fully ignored, because the color is still defined and controlled directly by the noise 3D that we added, and the scale is controlled by it as well. Okay, so we cannot change the noise here, it's still in Painter. Okay, what will be interesting now? I know. Let's add, for example, some complex stuff like maybe some textures directly in the shader. Okay, let's close this. So far, what we have used are only float and color values that are numbers. In the end, the noise 3D is a vector 3 color that is basically numbers, the metallic as well, and the roughness as well. But for example, let's say that what we want to add is not a value but a texture, right? So we can start first let me see here. I think that I have some textures exported. Okay, let me check the chat. Adding filters. What do you mean by adding filters? Like Substance Painter filters? Kennedy? Okay, well, let's continue for now. So for example, here I have, let me open the folder. Okay, here I have a material defined by textures, right? So for example, if I create a new substance graph, let's create it as PBR metallic roughness, and let's add all these textures here. Let's draw them here. Link it, okay. And this is the substance designer that we all know. We have a normal map. We view the outputs in 3D. Let's go here to OpenGL for that. We have a normal map. We have, what is this? A metallic. What is this one? Is the roughness. So let's add it to the roughness. We don't need this. We don't need this. This is a base color. Okay. We don't need this. This one is height. Okay. And this one is emissive. Let's change this and call it emissive. And here let's change it to emissive. Okay. The output's in 3D. And here we have a basic material defined in. It can be, for example, a SBS file, an SBSR, or textures like I have it here. Now, if we go to array, we sort of see something. What is happening? Okay, let's go to the graph. When you create the MaterialX graph here, by default it will add it will take the last traditional graph that you used and clicked view in 3D as a default input. Imagine that that map is connected here, and that is defined because here in the sampler, in the new graph, you basically define that here in the output that the channel that will be used will be, for example, in this case, roughness, and or normal or base color, and the plugin is taking that information and is assuming that is the input of this file of these default values. That's why I'm not sure if you can see it in the, you should be able to see it, that you can see the roughness here. The metalness probably is not, you cannot see it because it's basically black. But for example, if we go back to the graph, let's change the metallic, create a uniform color, and grayscale, let's set it to 1, and let's connect it to the metallic channel and view outputs in 3D. Now you can see that it's taking that white color, and the material in array that is taking the MaterialX graph looks metallic. Now if we go back to the new graph and connect the black one again view output in 3D, you can see that the material no longer looks metallic, right? It's the same. This is basically the same effect that is happening with the layer stack in Painter. It's replacing the value that is defined hard coded here by the value that is receiving, in this case, from the traditional graph, and on Painter by the layer stack. Okay, let's check the chat. TT Petra, hi, I am unable to view the stream for some strange reason. Can you try reloading? I know that at the moment YouTube is also lowering the quality of some of the streams because there are a lot of people using it right now. C. Adams says there was a presentation between Substance 3D folks and ILM about MaterialX, August 10, 19. Do you want me to link it for further follow-up? Yeah, that will be great. In the end, the more information that we can have right now, the better. Campy3D is asking, so when you say the matrix graph takes the input from the substance graph, how does that work on export? Okay, in export it doesn't work at all. In export, the MaterialX graph only knows that they can receive an input that can be used in that channel, and it's part of its job of the implementation to connect that interpretation of material with this shader network that we're creating with MaterialX. Okay, that's why it's working in Painter, and in Painter is taking the layer stack, is not taking actually anything that I have here in Designer. And we can see it in a while. For example, let's also connect the color to see it the same way. Okay, so here we create a color. We connect the color to the base color. Again, we expose it, and when we expose it here, we know that the color should be sRGB, and we know the sample usage should be base color. So if we go to base color like this, and then we go back here to the substance graph, to the outputs in 3D. In theory, it should be available now. Here in iRay, you can see now the base color is showing up. And here you can see that what is showing is the designer input defined, that in this case is this lava material. So if we export paint to Painter, again, we do all the steps of copying it from Substance Designer to the shelf in Painter and opening Painter. I'll have to add it in the comments. Yes, please add it in the comments, C. Adams. If once I found it, I'll also add it to the description, so everyone can have access to it. I'm not sure how to configure the chat at the moment. Sorry about that. Okay. Now let's open. And let's change this again to the MaterialX. Now what we see here is that even now I changed the shader to use the MaterialX graph shader that we created, but now it's no longer showing the noise. It's actually showing what is in the layer stack. If I don't have anything, it shows the default value that are hard-coded, in this case black, 1 in metallic and 0 in roughness. So for example, if we change this default to be red, for example, let's export it again, and let's close it again, copy and paste, we open Painter, Okay, in the meantime, let's check the chat. Everything. Okay, Campy3D says, so you can reprocess the entire layer stack below in Painter or just lay the layer directly below? You could reprocess everything because what you are doing is routing the layer stack to the shader, and that way the shader is taking into account the layer stack in that particular channel to do the rendering. Then Campy again says, I mean, let's say you write a blur in the MaterialX and take it into Painter. Does it then blur the entire results of the layer stack, or just the layer below? The entire results, because the layers first Painter processes the layer stack, and then after processing the layer stack, it overrides it. It implements the shader. It's similar. Imagine that you export the textures from Substance Painter, and then you add it, for example, in Maya to the hypershade. In the hypershade, you add a blur. You import the texture first with a file 2D node and a texture node or a file node in Maya, sorry. And then the output of that file node, you add a blur effect or a mask or whatever over it. Then the final render will first get information from the layer stack or from that file node, and then put that mask or whatever other effect that you add after that. So the end result will show also show both the file with all the images and the mask or whatever effect that you are adding over it. Okay, I think. Oh, okay. I have it now. I have the link that CAMs was talking about. So let's add it here. I add it to the chat, but Arthur, I think that you can help me by adding it to the description of the video, right? Okay, let's continue. So now we open again the file, open preview sphere. Again, we change the shader to the one that we're working on. And let's delete everything. Okay, I was expecting this to be red. Maybe I missed something. Here in theory, we're getting a red by default. Okay, well, that's part of the process of figuring out and exploring what MaterialX can do, right? Again, we see these views 3D view, and we get back to the lava material. Now let's add something a little bit different. For example, this is the other way I found that you can add textures. There is a node called texture 2D. Here you need to have, for it to work in Designer, you need to have the texture in the resources. So for example, let's add this base color. Here we click from resource and select the base color. Now we have it here, but for some reason, if you zoom it out, you see that the base color, while here in the 2D view you can see it with the correct color space, in the graph you can see that it seems like it's applying the sRGB again, so it looks a lot brighter. So first we need to get an image color node to translate for the output texture 2D to a color output, and then there is one that is called alg. Let me find it. sRGB to linear. Then we can connect this one, the base color, and we can get exactly the same result. if I connect it directly without the ALG sRGB to linear, you can see how it seems like it's applying the sRGB curve twice because the texture is already in sRGB. Okay, so we have here the correct result. And if we, instead of using this expose, we connect it this way and we export to Painter, let's see what we get. Again, let's copy this one, delete this one and paste it here. Then we open Painter, and in the meantime let's check the chat again. So there is no way to parent it just to a layer. I don't think there is a way to parent it to a layer if you're going to use it in Painter because of the way Painter works. But for example, you can create different inputs in Designer to use different materials, and when you import it to, for example, Arnold or some other renderer that supports GLS, this kind of shaders, the GLSL shaders or directly MaterialX shaders, you can have different material inputs there. Okay, let's select the material here, and what we get here first is, again, the same rules work for the roughness and let's close this. For the roughness, as you can see, the same rule applies, that still the layer stack is the one that is controlling the roughness and the metalness, as you can see here. But even when we added a color via texture, there is no, we didn't create the connection for Painter to use the layer stack. So now if we add a new fill layer and say we only want to use the color and change the color, nothing changes. But unlike the first time that we didn't have any option, here we find that we have a select texture with a node image color 3.6 file. So for example, one thing that we can do here, it's for example, we select here the base color, we add it to the shelf, texture, transition, import, and we add it here, and now it's working as expected, right? We can see the texture is working. The colors is being controlled by this image that we add here, while the roughness and the metalness is controlled by the layer stack, as you can see here. So with this we can think, for example, of a lot of more complex stuff. We can probably add a parameter to the, and maybe that could be some sort of example of what you were trying to achieve Campy 3D, that we can add some texture maps directly on the shader at shader level, like I showed with the base color, while also adding some via the texture layer, and we can that way combine a lot of materials. Another option will be that we can create here, as you remember here, we can select different channels, right? And we can basically reconnect those channels to whatever we want. So for example, let's do something crazy. Let's see if this works. I haven't tried yet, but I think that it can probably work. Let me see the chat quickly. Is that export painter natively inside Designer, right? You mean this button export painter? This is part of the plugin. It's not natively in Designer. So you need to first download and install the MaterialX plugin. Okay. So this is my crazy idea. For example, imagine that we have a color and we expose it. We say this is sRGB, and the sample usage that we're going to take is, and let's check what would be cool. For example, okay, let's use the diffuse channel. Okay, and we have a second one, another color. This one we expose it again. Again, this one is sRGB because it's a color, and we select here the base color. Okay, now let's see what we can do here. Both are colors. See. This is the luminance. But let's see. What I want to do is, this one is taking the base color channel, right? And this one is taking the diffuse channel. We know that base color and diffuse are different things. And actually in Painter, here we can, in the project, here we have only the base color channel, but we can also, if we want, add the diffuse, right? So what I want to do is, for example, take the diffuse channel, and with the diffuse channel do something, mixing it in some way with the, okay, let's maybe multiply. What happens if I add this? This one is the, let's start with the base color, and let's create the noise 3D. Noise 3D vector 3, noise 3D color, and let's connect this to the base color. So now we see some weird stuff that is happening, right? Because we are multiplying the noise with the base color channel. This is something similar to what I was talking about with Campy 3D, that after receiving the result from the layer stack, we can add any other operation, and the operation will be at shader level, not on material level. That will be applied after the layer stack in Painter. Okay. So, and the other thing that I wanted to try was, for example, to show a little bit more about how the channels are working in Painter. Is, for example, here we have defined the diffuse channel, and we'll use the diffuse channel to guide the emission color, right? So now here in emission, the emission is defined by this guy that is using the diffuse channel, and let's add another float just to control the emission level. So I connected the flow to the emission. It's right at the moment it's 0. So, but let's set it up by default, for example, all the way to 2. Okay, now with that, let's expose this one so we can modify it at the shader. This one is a linear value. The sampler usage doesn't matter because the emission level is controlled at shader, not via the content of the stack. But maybe we're going to change the identifier. So we set this one to emission, and we export Painter. Again, let's open the other. Here we are. Let's copy again from here to here. Let's close and open Painter again. Kennedy is asking, well, so will that make it faster to send it to Painter without reloading Painter? I'm not sure I understand what you're talking about, the material, because what we're actually doing is sending to Painter. What it does, it doesn't actually send it to Painter. As you can see in the process, what it does is exports the shader to a folder called Painter that is in Documents Algorithmic Substance Designer MaterialX, and we need to copy that shader to the shelf of Painter, so that way Painter can recognize it, right? Again, we open the preview sphere, and we select the MaterialX. And as you can see, if we delete all this stuff and we add, for example, single color, now let's add also the roughness and the metal, so we can have a little bit more control. This close this one. Here you can see that we see again the noise, and if we change the color, we can see that the noise is affecting the layers, but after everything in the layers is happening. Let's add a little bit something more complex like this one. I went again only with the color. And you can see that the color is being multiplied by the 3D noise. The 3D noise is large at the moment because we removed here the position in the 3D noise, so we no longer have control over that at the shader level. But for example, something that we can control is the emission level. Now, if you remember correctly, what we did here was create a color and expose it, but we expose and connect it to the diffuse channel. So now here, if we add, for example, let's add another layer, and in the channels, let's add 2 channels. Let's add a diffuse channel, and let's add an emissive channel. Okay, now here, if I enable emissive channel only, you will see that it's not working at all. Something is showing. That mainly is because here I have the emissive intensity, but you can see that the emissive, sorry, this one, the emission here, that is showing, but nothing, but it's using a default white value, right? And for example, if I remove here the diffuse channel, in theory, the emission won't work anymore, even if I have the emissive channel. And that is because here, instead of setting the sampler usage to emission, to emissive, we set it to diffuse. What does that mean? That what we need here is actually a diffuse channel, and we need to have this free layer affect the diffuse channel. For example, let's set it something like this. And now at shader level, we can actually see the value of the emission. Okay, what that shows us is that this sample usage, you can use it as any way that you want to. So you can take that to your advantage, because for example, you can use the specular glossiness and all that and add it to the shader, or the different scatterings, or whichever other sample users that you are not using in the PBR normal. And that way you can control, for example, Campy 3D. With that kind of shader creation, you can control the kind of different layers, only affecting different layers depending on the channels that they are using. So for you, if you create your own shader, you don't really care about this convention of base color, high, roughness, metallic, normal, because these channels can be whatever you want to. Okay, that might solve the multiple materials issue that you wanted. I haven't tested it, but probably there are some ways to create some custom channels, because for example here you can write whatever you want. Probably that can be a way to do it, but I still need to try that out. Okay, we can, let's remove the emissive for now, and let's add here again the position, again the same as at the beginning of the stream. Let's multiply it by a float tree, and let's set this one to 10, for example. Or even more, maybe set it to 50. Okay, and let's export it again. Now again, we copy this from the designer documents and add it to the shelf, and we close and open again Painter. Okay, now let's open again the preview here, and let's change this one for the MaterialX one. Okay, now if we add a material, now it's easier to see how the shader is applying the 3D noise. I didn't expose it, so we cannot control it. For example, if we expose it and say, yeah, we don't need a usage here. If we expose it and export it again, let me close Painter and open it again quickly. And let's open Painter. And in the meantime, let's talk a little bit about what we are doing. As you can see, what we are doing here is we are getting the base color from, in this case, from this other graph that we have, that is a substance graph, a normal substance graph, and we are applying at shader level and multiply with a 3D noise. So we are getting a different result. Okay, what that means in Painter is that anything that is on the layer, on the layer stack, will be multiplied in the end by this 3D noise that we added here, and in the render we'll see the, for example, let's add a simpler material. We'll see this multiplied by the 3D noise. Okay, as you can see here, we can see the color multiplied by the 3D noise. Let's take this base color channel. If you see the base color channel, since all the effects are done at shader level, you cannot really see any change here. But if you see the final render, you can see the noise, and we can modify here the noise that is multiplying over this aluminum insulator material. Let's try it with another material. Here we don't see, well, for example, we don't see anything because it's multiplying by black with black. For example, if we add a simple white color, we see the final result of the multiplication. Let's move the metallic and let's reduce the roughness a little bit. We can see the noise, only the noise. Okay, let's say like this, something like this. Right, so now if we change the color is being multiplied by the 3D noise that we added, and we can control here at shader level how the 3D noise works. I'll try to do I mean, in the end, this is just exploring and trying to understand how Designer and Painter interacts with the new MaterialX plugin. I'll try to do some more complex shaders that actually show something that is more like a real life example in the future. I'll do a tutorial about that, and probably also share the file so everyone can check it out. But before we end this stream, I think that we've gone for around an hour and a half. Before we end it, I wanted to try something that is a little bit more complex, that is actually the normal map. Okay, because so far we added the textures two ways, or by adding a color and exposing it, like here, and then setting the gamma type and the sampler usage, or by adding this node called texture 2D that you can then connect directly to the shader. But with normal maps, it's a little bit different. So let's see. According to the instructions from the plugin, here is this section, normal maps. It says there is a default behavior for converting directly exposed flow tree normal maps to world space, which is inconsistent between the GLSL viewport and the iRay viewport. For normal maps, please use and then the instructions. So let's try that. That way, probably it will help you guys understand how it works. So when you try to replicate it by your own, you won't have any issues. So it says first we need to use a texture 2D node, that is this one, right? Then here let's select from resource and select normal. So now we have here a normal map. Then it says use an image vector for getting the value. So image vector 3, and now we have a flow tree. Okay, remember that the normal maps have three values, one in the red, then green and blue channels. Then it says okay, and it says use the gamma linear, and use the alg normal TS to WS. Okay, now we connect this one here, and we connect this one to the normal. And as you can see here, now the normal information is showing up nicely. But it says first that we need to use the gamma linear, and I don't see here any information for gamma linear. So probably what we need to do is add here and expose again. Here set it to linear, and the sample select the normal. Let's see if that works. Okay, now we have the color. Let's remove all these, multiply to try to replicate how the shader works normally. Now in this, we basically replicated the PBR shader, right? We have a base color, we have a metallic, we have a roughness, and here we have a normal. Let's see how this works. So let's close again Painter. Let's copy again the new shader, replace it, and if we open Painter, in theory, now since everything is connected and the sample usage is set correctly, in theory, now if we add a material to the layer stack, we should be able to see the material working as we usually see it on Painter, right? So let's remove this. Let's select the MaterialX shader, and let's okay, something is not working. For some reason it's working here, but okay, I think I know what it's. If we enable normal, here is working, right? We didn't add anything for the height yet, so of course this is the look without normal map, but now we can see a PBR shader working as expected, right? So for example, if we change the material, something different, here this lava that we were using on Designer, enable the height and enable the normal, and it's looking as expected, right? So basically with this setup, we created the basic PBR shader. Now with MaterialX, in theory we can export this and import it in another 3 application. Probably I'll try it out and show it in a tutorial or in a stream. I think that the 1 hour and a half is good enough for now. I hope you guys learned something, and I don't know if you have, I'll give a little bit of time to answer any questions if you have one of what we saw here, or well, anything else if I can answer it. So ask away if you have any doubts. Well, in the meantime, give you some time for questions. Let me show you full project I'm working on in Painter right now. This is a project I really like to create some traditional art projects that from different countries. This is one of the latest. I don't think I'm able to open the painter project at the moment. Let me see, because it's a little bit heavy. Well, but I've been hand painting this guy in Painter for a while. I hope to end it soon. It started all with a concept with this here in my station with this head. I only wanted to do a test of how to create this kind of material. It's called Wishol, but I ended up liking a lot the results that I decided to render it and do it all the way, the full body of this guy. Okay, let's see one question. Well, that whole thing for me is black magic, so no questions for me. Okay, you ran Phantom, don't worry. Probably will get clearer soon enough. It's basically what we're doing here is creating shaders from scratch in Designer that we can use in theory in any other software. Okay, any other question? Okay, you ran Phantom and then printed with color sandstone or something. I would like to. I assume that you're talking about the Jaguar. Yeah, I would love to paint it, to print it, and then have it as a figurine in my desktop. See. Okay, I think that there are no questions. I understand because it's a little bit difficult topic. So first you need to try some stuff and then you can get some of your questions ready. Oh, it actually loaded. Here is the project. A lot of layers. Really heavy project. Anyway, if you guys have any question, don't hesitate to contact me. I think that this will be all for now. If you enjoyed the stream, like and subscribe. I'll try to do this more often and explain a lot of stuff. If you want to see more videos like this or have some ideas of videos you want to see, please comment below. And you can contact me via Twitter, Discord, or Instagram. All the links will be on the description box. And remember, stay safe these times. So see you in the next one. Bye guys. Have a nice week.